Hey guys, welcome back to the channel. Today we'll practice some questions. I'll explain it to you. So as you can see, we do have one input, second input, third input, and fourth input. If you press the first input, y0 will be on. If you press second input, y1 will be on. If you press third input, y2 will be on. If you press the fourth input, all other outputs will be off. We'll make this. So let's get back to WPL soft. We'll add no contact ldx0 and out y0. Then we'll add ldx1 out y1. Then we'll add ldx2 out y2. Then we'll add ld. Rather than using ldx3, what we'll do, we'll add ldx3 in series. ldi x3. That is NC contact. Then LDI x3, then again LDI x3. Don't forget to place an end and enter. It's not taking. Okay, we'll do END. Now we'll save it. Practice question, save. Now we'll just simulate it if it's working or not. We'll go online. Now we are online. Now we'll start PLC. If you press first button, y0 is on. If you press second button, y1 is on. If you press third button, y2 is on. Now, if you press a fourth button, everything will be off. This is it. Now we'll go ahead and practice some few more questions. Now we do have x0, x1, x2, x3. So when we press x0, y0 will be on. When we press x1, y will be on, and y0 will be off. When we press x2, y2 will be on, and y1 will be off. When we press x3, y3 will be on, and y2 will be off. Now let's make it. LDX0 out y0, LDX1 out y1, LDX2 out y2, LDX3 out y3, E and D. Okay, so now if we press and turn on x1, y0 will be energized, and if you press x0, y0 will be energized. If you press x1, y1 will be energized, and y0 will be turned off. So we'll have to add an NC contact here. So LDI y1 here, LDI y2 here, we have LDI y3. Let's go back to the question. If you okay, now I'll decide LDI x7 to of the last input. We'll save it. Now we'll run the simulation. Now if you press first button, x0 is on. If you press second button, uh, y1 is on and y0 is off. If you press third button, oh, there seems to be a problem here. Can you figure it out? Just think about it. What went wrong? Uh, just imagine this as push buttons x0, x1, x2, x3, and no push buttons. If you on this, it will be on. If you on this, it will be on. This will be off. We'll just turn off. We'll just turn off this. If you on this, y2 will be on, and if we turn on this, y2 will be off. Okay, this was it. We'll just turn it off. We'll go to next question. If you have any queries, feel free to ask in comment section. We'll go offline, control plus 8, delete all this, and we'll go on to the next question. Question number 3. Okay, so what do we have to do here? What we have here? If you press x0 and x1, y0 is on. If you press x2 and x3, y1 is on. If you press x4 and x5, y2 is on. If you press x6 and x7, all other outputs will be off. That is y0, y1 and y2 will be off. We'll do that. Now LD x0, LD x1, OUT out, y0, LD x2, LD x3, out, y1, LD x4, LD x5, out, y2, LD x6, LD x7, out, y3. Now we'll just add LDI by 3 here. Okay, we'll do the same for the rest. We'll just control plus C and paste it here. It's not working. LDI by 3, LDI by 3, and now we are done with the program. We'll just add an end. Now run the program. Now if we push x0 and x1 on, we'll have an output y0. If we press x2 and x3 on, we'll have an output y1. If we press x4 and x5, we'll have an output y2. Now if we press x6 and x7, every other output that was energized, that will be off. I'll just turn it off. Now if we release, you can see NC contacts has been energized again. Okay, so now we'll just go offline and proceed further. What we'll do now, is we'll see next question. Now, if you can see, if you press x0 and x1, y0 is on, and if you press x2 and x3, y0 is off. We'll just make it then. Okay, so just let's make it LD x0, LD x1, then OUT out, y0. We'll add here LD I x2, and then in the parallel LDI x3. So as you can see, we just made it. We'll put an end to the program. Control plus S. We'll run it. Okay, so if we give input x0 and x1, y0 will be on, and if we press x2 and x3, our output is off.
So now
This is
we'll
the
see holding of a circuit. What we usually do in holding of a circuit, we use the output of the circuit as an input to hold the circuit. I'll show you. You will understand as soon as you see it. What we'll do is we'll add LD x0 and out y0. What we'll do is add a stop button LD and x7. Okay. So now we'll add LD y0. This LD visor is the holding parameter which holds the circuit even if we have turned off the circuit. Circuit in the sense if you have released the X0 push button. See, if you do set to on and then do set to off, the output is still energized. And if we do set to on, it's turned off. This is a simple concept. Now we'll make XOR and XNOR gate using positive and negative triggering. What we'll do is I'll just explain you what the positive and negative triggering is. As you can see here, we have an negative to positive and positive to negative. If we press an input, as soon as we press and use NP, it will give an direct pulse to whatever being required to. If we use N to P, that is and P to N, as soon as we release the push button, it will send an output. So we'll just use it and make an X OR gate. LD X0 out. We'll be using memory. To use memory, we have M0, and it will go on forward. So LD M0, then LD M0. Um, then we'll use LDI M1. Okay. Now what we'll do is LDI M0, NC contact of M0, and NO contact of M1, and we'll connect this branch and out M1. Okay, so now this is a basic XNOR circuit. But wait, we have not used a positive negative triggering. We just have to add it near the input. If we have used negative to positive. So now, if the pulse is high, it will generate a signal. So you can see we have an output. Okay. So what we can do, we can use LDM1 to operate an output. Okay, so we'll just use it. Okay, so now if we give one input and it's on, if we give another input, it will be off. Now we'll make an X NOR gate. What we'll do is we'll add LDM1 and out M2. What we'll do here, LDM2, LDI M3, and out M3. We'll do LDI M3, sorry, M2, and we'll do LDM3. We'll connect this two branches and replace M3. We'll go here. I just use Control Y to delete that run. Now we'll go online. This is our XNOR gate. So if we give two pulses, it will be turned on. Now if we give another two pulses, it will be off. What seems to be the problem here? Just give me a minute, I'll solve this issue. Okay, so if we set to on, it is on. Now if I give another command, stop, we'll just stop the PLC. What seems to be the problem? Waited for today. Thank you. The problem. We'll just go ahead and simulate it. Okay, so now if we give one pulse, it will be on. If we give another pulse, it will be on. So see, on, off. Okay, this was our XNOR gate. Now, what we'll do, we'll make an DOL circuit. We'll do LDX0, LDIX7, and we'll use and holding LDY0. So now we'll use this to connect our run out Y0 and an OLRC. LD, let's suppose X1. Now our X7, this is our OLRC, and this is our stop button, STOP, and X0 is our start button. We'll just go here, click here, and okay, this is a chart you can go through here to edit the commands, and for to go back you can click on ladder diagram mode. We'll be back here now, and if we simulate this, okay, so now if we run the motor, it will be on. But what's the problem? We don't have an NC contact here, so we'll just have to change it. LDI X1. Okay, it will run now. So if we give an input, we have an output. If there is an overload on the machine, OLRC will trip, and the machine will be off. Again, we set to on. If we have to manually off it, we'll just use X7 and we'll set it to on, and it's off.